If you are a triple science or higher tier combined science student, do not skip this video. I will show you how to calculate bond energy. What is bond energy? Bond energy, otherwise called bond enthalpy, is the energy required to break 1 mole of a specified covalent bond in the gas state. Here are some examples of bond energies. You would have noticed that the bond energy has a unit, and the unit is kilojoules per mole. Also, the oxygen to oxygen double bond has a bond energy of 498 kilojoules per mole, which is a higher number than a hydrogen to hydrogen single bond and an oxygen to hydrogen bond. This means that more energy is required to break an oxygen to oxygen double bond in order to form oxygen atoms. During a chemical reaction, all the bonds in the reactants are broken and new bonds are formed in the products. And so, energy must be supplied to break existing bonds, which we say is an endothermic process, and energy is released when new bonds are formed, which is an exothermic process. Let us look at a sample exam question. Chlorine reacts with hydrogen to produce hydrogen chloride. In the table, you are provided with the bond dissociation energies. Use the values in the table to calculate the enthalpy change for the reaction. If you are confused about what an enthalpy change is, it's the same thing as saying the energy change. Now let's look at our equation. We have hydrogen, chlorine, and then we have 2 moles of hydrogen chloride. We're going to use the balanced symbol equation and the data set in the table to calculate the enthalpy change. Now we need to look at the reactants side of the table. We have hydrogen and we have chlorine. What is the bond energy of 1 mole of hydrogen? 436 is correct. Now, what is the bond energy of 1 mole of chlorine gas? 243 kilojoules per mole. Wonderful. Let's not forget those units. Now that we have the bond energy for the reactants, we are going to find the sum of that. So that is equal to 679 kilojoules per mole. Now let's look at the product side. What is the bond energy of 1 mole of hydrogen to chlorine bond? Good, 432. But if you look at your balanced equation, there are 2 moles of HCl. And so we must times 432 by 2. Well done. We need to calculate the enthalpy change, which is equal to bonds broken minus bonds formed. So that is 679 kilojoules per mole minus 864 kilojoules per mole. Your answer is minus 185 kilojoules per mole. The reaction is exothermic, as more energy released making bonds than breaking bonds. But let's put that into context. This simply means that your energy from your bonds formed was greater than the energy from your bonds broken. So the energy for bonds formed was 864 kilojoules per mole, and from bonds broken was 679 kilojoules per mole. Exam question 2 is a bit more challenging, but let us look at how we would approach a question like this. Look at the reaction. Focus on the reactant side for now and tell me how many bonds can you spot. If you spotted a carbon to hydrogen bond, wonderful. How many of those do you see in this compound? There are 4 of those bonds. Now, did you notice that there is a coefficient in front of the compound? Yes, 2. So that means you have to times the number of bonds by 2. So in total, we have 4 times 2 CH bond, which is 8. Then we have an oxygen to oxygen double bond, and there's only one of those bonds. Now let's look at the product side. There's an O or oxygen to hydrogen bond. Then we have a carbon to oxygen bond. And then we have a carbon to hydrogen bond. So in total, we have 3 carbon to hydrogen bonds, 1 carbon to oxygen bond, 1 oxygen to hydrogen bond. And again, we have a coefficient of 2. So we times those by the total number of bonds. So it is 2 times the number of bonds that we counted earlier. Now that we have this information, we can calculate the bond energies for the reactants and for the products. Let's do it. So the total bond energy for the reactants is 3,977 kilojoules per mole. For the products, it is 4,210 kilojoules per mole. We're still not done. Let us now calculate the enthalpy change. Energy taken in minus energy released. So it is 3,977 minus 4,210, which is equal to minus 233 kilojoules per mole. Is the reaction endothermic or exothermic? You are correct. The reaction is exothermic, as more energy released making bonds than breaking bonds. Again, this means that your energy released is higher in value than the energy taken in. Follow for more science revision.